Okay, you guys are going to try the first one. 2 sine theta equals 1 between 0 and 360. Go. It's a review from yesterday. 2 sine theta equals 1. I have a degree 1, so what am I going to have to do? Math. That is true. What kind of math am I going to have to do? Get the sine theta by itself. Whenever you have a single one, you have to get it by yourself. Remember, if you're confused as to what to do, you can always replace it with an M. Might help. Okay, this one we're going to go 2 sine theta equals 1, and then we're going to divide by 2. So sine theta equals a half, a positive a half, which is in quadrants 1 and 2, here and here, because sine is positive in quadrant 1 and quadrant 2. So it's going to be at 30 and 150. What we're going to do today is we're going to go over ones that don't directly follow right on the unit circle in the exact values. They're on the unit circle, but they're not in the exact values. So we're going to follow 3 steps. So what you do is you isolate it first like we did. And if you see that it's on the unit circle, go ahead, take it off the unit circle, right? If it's not, you have to follow the 3 steps. So the first step is reference angle. And we're going to show it doing this example because I can do it. The 3 steps that I'm going to teach you, you can do for every example. But the way you went, when we went over it yesterday, they were only ones that were right directly off the unit circle. So if you couldn't pull them directly off the unit circle, then you'd be sitting there not knowing what to do. But the 3 steps always work. So the first step is to find the reference angle. So we do reference theta. Now the reference angle is your little angle between 0 and 90, right? It's always the angle from the x-axis to the terminating arm. We went over that. Now, in quadrant 1 is where you'll find all of the reference angles. The reference angles are equal to the angles here. So like in quadrant 2, I would have to take 180 minus it and I get my reference angle. In quadrant 3, I take 180 plus it and I get my that angle minus 180, I get my reference angle. 360 minus the angle, I get my reference angle. But in quadrant 1, what my angle is my reference angle, correct? We agree? So in quadrant 1, the angle is actually the reference angle. What's positive in quadrant 1? Everything. So if I want to find a reference angle, the fastest way to do that is to actually find the positive of whatever I'm looking for. So in this case, it's sine theta equals a half. We agree? It's sine theta equals a half. It is a positive a half. But if it wasn't a positive a half, we'd still find the angle for positive a half. How do we get angles? Well, we were taught this in grade 10. You do theta equals. How do I get rid of the sign that's beside the theta? Sine neg 1. You'd sine neg 1 both sides, right? And then that sign would cancel off. And you'd have it on this side. Now the mode I want you to be in, remember when you go to press sine or cos or tan or second sine, second cos, second tan, you have to make sure you're in a mode. You slap your hand before you do it. So make sure you are in mode degree. The mode? It's right beside the second button. Very top. And then make sure you're in degree. Okay? Then you'll go second sine a half. Because before you press any of those buttons, you have to make sure you're in the mode you want to be in. And what do we get? So we get the reference theta is 30. We agree? Now that's the little angle between the x-axis and the terminating arm. Well, if we knew where the terminating arms were, we could, boom, we'd have an answer, right? How can we tell where the terminating arms are? So step 1 is reference angle. Step 2 is use cast rule to find your arms. So step 1, reference angle. Step 2 is cast rule. So I'm going to go draw my little quadrants. I go up to my question where it's solved here, right? I'm looking for when sine is positive a half. So I'll only get 2 quadrants where that can happen, right? Where is sine positive? quadrants 1 and 2 because of cast. C, all are here. S is positive here. T is positive here, right? And now I can get my answers right away because as long as I have terminal arms and I have reference angles, I can get my answers. So I know the reference angles to these are 30. Well, I already have quadrant 1 then because my reference angle is equal to the angle. How would I get this one? 180 minus 30. So it would be at 150, and I have my two solutions. The exact thing. So your first step is to get the reference angle. Your second step is to use cast welding terminating arms. And then your third step is just get the angles. Right? Okay. We're going to look at number 2. Number 2, does that look like it's right off the unit circle? No. Now, it is 0 to 2 pi, but you guys are probably going to stick into radians and then convert at the end, which is absolutely fine if that's the way you want to go. Most of you will. So we still have to get the reference angle, right? First step. Now, all the ones we learned yesterday, could we have done reference angle, terminating arms, gotten answers, and not looked at our unit circle completely? Ah, we absolutely could have. Nothing wrong with that. So, step 1, reference theta. Because it's already in it's by itself, right? It's already by itself. So I have cos theta equals negative 0.8090. But I want the reference angle. So reference theta equals, bless you, cos neg 1. And what do I take to get the reference angle? Every single time? Which quadrant always gets you the reference angle? Quadrant 1. And what are they all in quadrant 1? Positive. So even though this says negative 0.8090, we're going to use positive to just get us the reference angle. We're going to use the negative for cast rule, though. In degrees? Yes. No, you'll get a different answer. You'll get it in quadrant 3, 2. So now, can we keep the answer, or do we have to like round, or what do we do? When are we allowed to round? When are we allowed to round? At the very last step. So please be patient with me. Does anyone have a calculator where you can't arrow up? There's going to be some of you. Okay? If you can't arrow up, normally you would have to retype all of these decimals out. We agree? That's not fun. So what you can do is you can store this decimal as a variable. So everyone who does not have the arrow where you can arrow up and take it, what you're going to do is you're going to, so you got the decimal, 36.00165, blah, blah, blah. You have that? We want to store it as our reference. So I'm going to store it as R. So I'm going to press stow, which is right above the on button. And actually everyone can follow along just in case you want to ever store something as a variable, you can. So you can go store alpha and then pick a variable. I'm going to pick R because it's reference. So I'm going to go store alpha times sign. So I've now stored it as R, right? So later, I just picked the R, yeah. You pick any variable. You can pick your variable for your letter. You can pick M. Some people like picking the So now it's stored as R, correct? Yeah. Everyone has it stored, and I'll show you how it's helpful. So, second step, cast rule to get our terminal arms. So how do we get to our terminal arms now? I go back to my original that I've isolated. I need when cos is negative. Where's cos negative? Yes. And sine and tan is where cos is negative. You are correct. So it's at 36, so it's like somewhere here and somewhere here, right? And then these are that reference angle of 36. So how would I get this one? This arrow. I go 180 minus that decimal, correct? So what are you going to do? You're going to go 180 minus r. Now, before we move on, people, 3, 4, 3, 5. At the end, I'm going to have to do what to all these? Turn them into radians. So what would I do? Degrees to radians, Dr. Pi on top, right? So I'm going to take that answer and I'm going to multiply it by bracket pi divided by 180 bracket. Because I want to keep that decimal. Degrees to radians, pi on top. So you're going to multiply it by pi over 180, right? So this theta here is actually 2.5 radians, right? When you multiply it by pi over 180. Now remember, I'm still stored as r, so how do I get this one? How do I get to this arm? I go 180 plus r, right? 180 plus r. And I'm going to get 216.00166565. But what do I have to remember to do? Times it by degrees to radians, pi on top, so pi over 180 in brackets. And I get theta equals 3.8. And both of those fall in between 0 and 2 pi, right? Now, if you don't know if they fall between 0 and 2 pi, you can go 0 and 2 times pi. Oh, okay, that's 6.2831, da, 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 da. Do both of these answers fall between 0 and 6.28, blah, blah, blah? Yes, so we're good. So theta equals 2.5, comma 3.8. So we still follow our 3 steps, hasn't changed. But if we're in degrees and the answer's in radians, we have to convert, yeah. Yeah. Number 3, yeah, sorry. Multiply by pi over 180, because remember degrees to radians, pi on top. So I just took my answer when I got it, and then multiplied by pi over 180 in brackets. Because I need to have my answer in radians. Number 3, what am I going to have to do first? It's a degree 1 ratio. Yeah, you have to get cotan by itself. Divide by 4. Cotan theta equals 1/4, which is great. So I can go cotan -1. Oh, wait, no, I can't, because I don't have a cotan -1 button. I do have its bestie, which is tan. So I just flip it and write it as a tan. So 4 over 1 or 4, right? And now I can do my 3 steps, just like I did before. Reference theta equals tan -1 of +4. Even if it was a -4, I would do +4. And what mode am I in? Degree, especially because this one is in degrees. And once again, with a degree symbol, I'm going to go store it as alpha multiplication sign. So I'm storing it as r. So step 1, reference angle, store it if you'd like. Okay. Step 2, and if you can arrow up, you can just take it from there too, right? So that's another option. Step 2, cast rule. So I go back to where I solved. Okay, tan x or tan theta equals +4. So I need to go where tan is positive, which is where? In all and tan. And this is 75 degrees, right? 75.96, blah, 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 degrees. And so is this. So the answer to the first one is 75.96 degrees. What's the answer to this one? 180 plus r. Which is great that I'm finding it. However, 255.96. My domain is what? 0 to 180. So that one's out of it. So why would they give you a restricted domain like that? Numeric response. One answer. Nope, because it's in degrees. 0 to 180. Yeah. When would you do that? No, because there's nothing in S. And if it was in quadrant 4, we'd go 360 minus it to find it. But we don't have to because it's in quadrants 1 and 3. Yep. Number 4, what do we have to do? We have a squared. We have a squared, but it's by itself. So we have to isolate it and then take the square root, and then you get plus or minus. So we divide by 4. Now, some people at this point want to flip it and put sine squared. Don't flip it until you actually have a single. So you first have to take the square root of it, and then you could flip it to make it a sine. Okay? So we want to get cos squared theta by itself, so we're going to square root both sides. And when we take the square root, we have to take plus or minus. So remember, when we have a single, a degree 2, that we're going to end up with 4 solutions. So I have cosecant theta equals 5 over 2, which is a really nice answer. But I don't have a second cosecant button. So I'm going to have to switch it to sine theta equals 2 over 5. And then I can carry on. And it's a positive 2 over 5, right? So I know casserole-wise, it's going to be in 1 and 2. Because just positive, like the actual fraction itself is positive, right? So it's where sine is positive. So it's here and here. So I can get my terminating arms right off the bat if I want to. Yeah. Well, it is plus or minus. But so then it's going to end up in each quadrant, right? But when we go to do the reference, we well, that one's not very accurate towards the other ones. That was a little wacky. When we go to the reference, we take the positive. But yes, I dropped it off by accident. So whenever you take the square root, yes. So when you take the square root, you always get plus or minus, right? So you're going to get it in all 4 quadrants, always. So if you forget to put the plus or minus sign, or you drop off the minus like I accidentally did, you're only going to get 2 of them. And they'll have the answer to that, right? Because it's common error. But when we go to do reference angle, we have to take the positive. Doesn't matter if it's positive or negative. So step 1. Reference theta equals sine neg 1 of 2/5. I don't care if it's negative. I'm taking the positive. Now this one's in radians again. So you can do it in degrees, but you have to remember to convert. So I'm going to store this as R because I have one of the older ones. But I like storing it even when I don't have the older ones, and I don't have to arrow up and try and find it. So I would store my reference angle as R. Store alpha R. Okay. Now I know it's in every quadrant. So my reference angle in here is actually equal to the angle, right? So I'm going to get 23 point all this angles. And what am I going to have to do, though? Multiply by pi over 180, because Dr. Pot, degrees to radians, pi on top. So I'm going to get 0.41. Then this one, I have to do what with my reference angle to get it? 180, yeah, 180 minus it. So I'm going to get 156.4218215 degrees, but I'm going to have to multiply by pi over 180. So I get 2.73. Then what do I do to get this arm? 180 plus the reference angle. So I get 203.57. You have to, because it's plus or minus. Because when you take the square root, you're going to get the positives and negatives. The positives are in quadrant 1 and 2 for sign. Yeah, so whenever you take plus or minus, you literally get 4 answers. You get one in every quadrant. It's actually the easiest, because you don't have to figure out where it needs to go. Take this answer of 203 and times it by pi divided by 180 in brackets. And I get 3.55. And then this one, I'm going to have to go 360 minus it, right? And I get 336.421815 degrees. I have to multiply that by pi over 180. And I get 5.87. So my answers are, oops, I ran off the edge. 0.41, 2.73, 3.55, 5.87. Yes, because it takes me 360 to get the whole way around. So if I just take off the reference angle, it'll give me where I'm at. Yes. Because that's the reference angle goes from the x-axis to the terminating line. So it takes me a whole 360 to go all the way around, and then I just subtract the reference angle off, and boom, I met that arm. Is it always going to be 2 and 3, like where how it's like 5.87? It depends on what they ask for. And then we wouldn't put it in scientific notation, right? Mm-mm. Okay. It's either 10th or 100th or. I always take all of. Oh, you mean the answers? The answers would have to specify what they would take them to. I just took them to 2. I think it's in yours 10th or 100th or whatever. They have to give you a rounding rule. F and G here, these two. You're going to try. Step 1, reference angle. Step 2, cast rule. So cos is positive. So here, in all and in C. This one is the answer. This one's 360 minus the answer. Which is 331.16 degrees. Or 2. 331.2. Doesn't matter what you round to unless they'll specify. So then this one's cos theta equals 5 over 1, so 1 over 5. So I'm going to do reference theta equals cos neg 1 of 1 over 5, which equals 78.46. For which? Like trig ratios? See, the answers to a trig ratio are actually units over units. So whatever the units would be, the units would cancel. They don't have units. Like it's of length. It's a length on a Cartesian plane, right? You could give it whatever unit you wanted to. Yeah, it could be whatever unit it wants, but they'd be gone because they would cancel each other off. Yeah, so that's why they don't have a unit, because they're a measurement of the xy on a Cartesian plane, but they'd be the same units, so they cancel. Yeah. Yes. So then I need where cos is positive again. So this one's 78.463 degrees, but I have to multiply it by pi over 180. And I get 1.4. And then this one I have to go 360 minus my angle. I get 281.53. If you are going to do it in degrees, though, you guys, you have to keep everything. You can only round at the end, right? Or your numeric response is going to be very sad, like very, very sad. .9. Homework. Cheer up.